The distribution here looks optimal.
Agreed. No dry spots or misplaced fibers detected.
The sensor flagged a void here at the leading edge.
Rework team notified. We need to check the layup pressure on the next run.
At the preform station, synchronized robotic arms meticulously lay the carbon fiber, ensuring precise orientation. Automated machinery begins drawing a vacuum, visibly compressing the carbon fiber and removing all trapped air.
Here in the clean room, specialized honeycomb core and aluminum spars for the Ka-27 Helix are prepared.
Scan confirms even cooling on the main body.
What about the joint tolerances? The heat signature is slightly high there.
Check the alignment metrics here. We are green across the board.
Verified. Proceed to next phase.
Secondary machining data confirms calibration.
All threads within tolerance, ready for the Ka-27 assembly. As the hydraulic lines are routed, robotic arms perform precise crimping. Pressurized inert gas test.
Pressure holding steady at max load.
The locking mechanism engaged perfectly on cycle 42. Data confirms stability.
Settings confirmed. The duration is holding steady at 4 minutes.
Pressure differential is stable. Seals are good.
Totals. This permanent marking links the physical component to its complete digital manufacturing history, including material.
Pressure levels are fluctuating slightly. It seems like.
It's within the acceptable parameters. Purity is confirmed.
Reaction time is critical here. What's the current temp reading?
20 degrees, holding steady according to the protocol.
All parameters are nominal for the Ka-27 reset.
Confirmed. We are ready for the next run.
Reviewing the final specs now, everything seems correct.
Agreed. The sticker confirms validation. We can sign off on the handover.
Final count confirmed against manifest.
Authorization approved. Proceed to secondary manufacturing.
All parameters nominal. Certifications clear. Acknowledged.
Integration sequence initiated.
Welcome to Process B, where the Ka-27 rotor blades are prepared for the curing cycle.
All green on the panel. Seal looks good. Confirmed.
Confirmed. Proceed with the cycle.
Check the alignment on Sector 4.
Looks good on the tablet. Stress levels are optimal.
Check the root section tolerance here. Looks good. Process B is complete.
Pressure nominal. Check the thermal curve.
Holding steady. Green light on the bond.
The temperature at the bond line is stabilizing right on target.
Yes, and the green light indicates the cure is complete.
The consistency looks optimal on the trailing edge.
Confirmed. Process B parameters are holding steady.
No signs of pitting or degradation here.
The coating thickness is uniform across the entire blade.
UV levels are optimal. The coating is stabilizing nicely.
Flawless cure confirmed on the Helix assembly.
See. Precisely weighed tungsten counterweights are robotically inserted and sealed.
The adhesion is strong, well within tolerance levels.
Confirmed. Process B compliance verified.
Transition is smooth. Locks engaged.
Confirmed. Process B successful. Data logged.
The profile looks good. All green and blue, well within tolerance.
Confirmed. The coating held the shape perfectly.
Flow rate reduced. Ensure complete purge of air bubbles. System pressurized. Volume confirmed. Green light on sequence complete.
The induction readings are completely uniform across the trailing edge.
Meets the durability specification. Process B is complete.
Backup complete. All Process B data is securely encrypted.
Verified.
All right, slowly raise the cradles. Watch the clearance on the starboard side. Copy that, lifting now. Clear on starboard. Bringing it down slowly. Check alignment at the root.
Looks good. Seating the blade now.
Okay, starting the sequence on the fasteners. Alignment diagnostic is green. All bolts secured.
Confirmed against the checklist. We are good for the ground test.
Roger that. Final sign-off complete.
Rotor assembly reports positive lock.
Diagnostics are green across the board. Ready for spin-up.
A helicopter ascends, demonstrating the structural integrity of the titanium mechanism and the aerodynamic performance of the precise composite airfoil.
Cuss! The Ka-27 Helix face the ultimate test in heavy seas. But steady! Clear to lock!
This folded configuration demonstrates the operational utility of the specialized design within the tight constraints of the hangar bay, providing reliable service in the most extreme operating environments. This is the ultimate success of a realistic industrial production pipeline.